Welcome to the Climate Hour. I'm your host, Bob Grove. Today we're going to talk about climate tipping points. Lately we've been talking a lot about climate politics, which is really not my favorite subject. Climate Hour's purpose has been to discuss climate science, to share the best in climate news, technology, and practices from experts in the field. Our goal has always been to help our listeners cope with global warming and the climate change that is upon us today. We've recently been forced to discuss politics because of institutionalized climate denialism. Recent guests have talked about how the oil industry has bought and captured our current U.S. administration and is now dictating environmental policy at the highest levels of government. That we now have elected leaders who are more interested in making another $1 billion off of oil exploitation than they are in saving 1 billion people's lives. And frankly, it's just hard to discuss climate science when government-driven climate hushing is now the rule of the land. So today, let's remind ourselves what real climate science tells us. Climate tipping points. These are critical thresholds that once crossed lead to an acceleration and irreversible change to our climate systems. For example, our greenhouse gas emissions melting the world's bright ice sheets and glaciers, which reduces the Earth's ability to reflect that hot solar radiation back into space. Or the melting of the permafrost, which will release large amounts of captured methane into the atmosphere. Once we cross the tipping point and the ice is gone, the Earth's surface will be darker and will absorb more solar heat. There'll be nothing we can do about that. And once we cross the tipping point and the permafrost melts, the atmosphere will be filled with methane, and the Earth's greenhouse gas effect will be out of control. And there will be nothing we can do about that. We have to take action before we reach these tipping points. And our best way of coping with climate change right now is to support leaders who believe in real science. So let's remind ourselves of what it is that the climate deniers are trying to hide. We're joined today on Zoom by Dr. Laura Pereira. Dr. Pereira is a professor in sustainability transformations and futures with the Global Change Institute at Wits University in South Africa and a researcher at the Stockholm Resilience Center in Sweden. Laura is an interdisciplinary scientist. She's trained in ecology, law, zoology, and human geography. She holds a doctorate in philosophy in geography and environmental science from the University of Oxford and has worked as a Giorgio Ruffalo and Undel Fellow in sustainability science with the Kennedy School of Government at Harvard University. Laura is the lead author of the Transformative Change Assessment Report by the Intergovernmental Science Policy Platform of Biodiversity and Economic Ecosystem Services. She's also the lead author of the United Nations Environmental Programme's 7th Global Environmental Outlook Assessment Report. Laura's interest lies in the role of future techniques and visioning to enable transformative change, in developing innovative methods for knowledge co-production in the Global South, and in building anticipatory governance capacity to address complex processes like tipping points. Hi, Laura.
Hi, well, great to be with you today.
Scientists have identified 9 major global tipping points: the collapse of the Greenland ice sheet, collapse of the West Antarctic ice sheet, the collapse of the SPG convection system in the North Atlantic, the collapse of the East Antarctic subglacial basins, collapse of the Amazon rainforest, collapse of the boreal permafrost, the collapse of the AMOC, which is an acronym for the Atlantic Meridional Overturning Circulation System, the collapse of Arctic sea ice, and the collapse of the East Antarctic ice sheet. That's a lot of ice. 6 of these tipping points are related to the melting of ice. 2 of the tipping points are the collapse of major ocean convection systems, and the other tipping point is the collapse of the Amazon rainforest. How important are these tipping points, and what role should they play in our decision-making process?
Thanks so much, Bob, for that great introduction on tipping points, and especially for defining AMOC so that I can just talk to AMOC from now on, because it is quite a mouthful, that one too. The majority of the sensitivity within our Earth system processes to climate is sitting within the cryosphere, is sitting within ice. And that obviously has repercussions for how we live on the planet at the moment. So the biggest implication really is for sea level rise, when we're looking at the melting of the West Antarctic ice sheet. In particular, we're looking at the Greenland ice sheet from that perspective too, and that just can cause sort of levels of sea level rise, where we're looking at small island states being extremely vulnerable to these impacts. This is an existential crisis that we're looking at. And it's, as you said earlier, this is not something that you can fix overnight. We're looking at millennia, if anything, of returning to a temperature sort of below what we had pre-industrial times in order to start to reaccumulate that ice. From the ocean circulation system, this is really interesting, because we're looking at impacts, both sort of fundamental, so literally the movement of heat from within the Atlantic, this is AMOC, from the tropical areas towards Europe. It's basically why Europe is why we can live there, why it's warm enough to actually live there, is because of AMOC, and it also sort of removes some of the excess heat that you see within, for example, the Caribbean. The breakdown on this would have devastating consequences. We're looking at, I think, a loss of between 3 to 5 degrees actually in Europe in terms of temperatures, which, from agriculture, people being able to live, survive, you're looking at countries that are already sort of sitting within the Arctic Circle in the north that would just become virtually unlivable. And similarly, looking at the tropics, sort of unbearable from that side. So that's really important. There also, and there's ongoing research. So I was part of the initial Global Tipping Points report that was published in 2023. And there was already a significant update when we published the 2025 report. So this is science that's constantly being updated with sort of increasing understanding of exactly where these thresholds are, what some of the uncertainties are. But for example, the impact of some of these ocean circulating systems on upwelling, that results in sort of these flourishing areas that a lot of our fish populations sit in. So off the southern coast of Africa, as well as in the Gulf of Guinea. So again, you can start to see this tight coupling between these Earth system processes and what humans need in order to survive.
Let's break down the cryosphere a little bit if we can, called ice-related tipping points. The Greenland ice sheet, I have scientists here in the climate area that tell me that tipping point's already been passed. I mean, it is melting now. That ice sheet has an average depth of over 1,600 meters. That's about a mile thick for those of us that use miles. And that's basically enough water to raise sea level by 7 meters, about 24 feet. What are the direct social and ecological impacts of sea level coming up a good 20 feet?
Yeah. I mean, if you just look at all of our coastal zones, right? We're looking at cities like Lagos, for instance, which is already quite near to water. We're looking at cities like Venice that are already sort of very close to being sort of waterlogged. We're looking at small island states having also, maybe no longer being around, right? And I mean, this is, again, as I was saying, it's an existential impact that we're looking at from sea level rise. And this is also very interesting, because prior to sort of tipping point science, this idea of these thresholds, these nonlinear feedbacks, these self-reinforcing feedbacks that continue a particular process. So again, it's not something that, you switch the button on and then you can switch the button off and the process stops. This continues to go until you're actually able to shift the entire system back in. Some of them are irreversible. So, prior to this, we would be thinking of, okay, sea level rise of, a couple of meters, maybe this is something we can build sea walls, for example, learning from the Netherlands, that we could actually hold back some of these water and sort of adapt to these sorts of impacts. The problem is when you're looking at 5-7 meters, and this is from 2100 and onwards, again, just because it might not be happening in the next 20-30 years, but it will eventually be happening. It's a process that we can't stop now that will have impacts, for example, in 2100. We're looking at these intergenerational impacts for these parts of the world that would be facing massive migration, right? If you no longer actually have ground on which to live, you don't have your ancestral connections to this place. There are multiple implications to this. So that's just from the physical land, right? Sort of encroaching. There are also obviously going to be other implications for fisheries, for temperatures. There's changes in salinity, right? Because this is fresh water that actually starts to move in, which is the implication that you have for some of those circulatory systems. So they're compounding impacts all the way down the system. And I think the scariest or the most important aspect to emphasize from the tipping point science is this long-term implication. We're looking at sort of timescales of millennia, right, for some of these processes to get back to what the conditions were in which human society started to flourish, right? Yeah.
And those seem like large dates, 2050, 2100. But you and I are going to be around 2050. We're going to live through that. And 2100, our children will be there.
Exactly.
Another one of the most immediate tipping points is the collapse of Arctic sea ice. Now, this is a much thinner layer of ice, but it covers what, 15.5 million square kilometers? That's like 3.8 billion acres. With that gone, it's not so much the sea level rise, but it's about the planet's albedo, our ability to reflect that solar radiation back into space. Can you talk about that?
For sure. So sort of basic sort of climate science is sort of, you get a lot of heat coming in from the sun, and most of the atmosphere actually sort of bounces that heat back. That's when we're talking at the role of greenhouse gases, which actually don't bounce back, which allow the rays that do come in to start actually reflecting back and forth from our atmosphere back in and sort of holding that heat. It's why it's called the greenhouse effect. It's kind of like what happens when you're in a greenhouse. Yeah, it's sort of that excess heat that you get. But the importance of albedo, sort of these white areas that don't absorb the heat but actually reflect it back, allow for cooling processes. This is, again, basic climate science. So obviously, you can get what we call a positive feedback loop, where you have these areas of sea ice, of white, in essence, that causes the albedo effect, where you have this bouncing back. But obviously, with the increase in heat, you have a reduction in the extent of the amount of white that is allowed, that allows the heat to be reflected back, which then leads to more increasing heat, which leads to an increasing amount of sea ice being lost, which leads to a decrease in the albedo effect. And you can see these sort of positive feedback loops that eventually spiral out of turn, and can lead to a tipping point. The important thing, I think, to emphasize from the Arctic sea ice perspective is that we have both winter sea ice and summer sea ice. And as you say, there's this Earth system process, which is really important for the albedo effect of just maintaining that sea ice. But when you look at the reliance of, in particular, marine mammals on the access to ice in order to be able to capture food, we're looking at polar bears, we're looking at sort of largely those large megafauna, our charismatic megafauna that we really want to protect largely, and also the cultural significance that, for example, caribou, etc., have in some of these areas. They are largely reliant also on the sea ice, on actually having something stable across which that they can hunt and walk and live, etc. So there are severe implications, not just for these Earth system processes, which are important, but also just real living creatures that rely on these systems, that have adapted their entire lifestyles to having the existence of the sea ice in different parts, particularly in winter. The economic implications for not having sea ice in the north is that, we can suddenly have shipping across the north. We don't have to rely on these other areas. So there are certain countries and certain geographies that are like, well, this is not a problem, because now suddenly we can actually move goods around, and sort of some of those, what I would call perverse incentives of, we're going to sacrifice like our entire Earth system functioning, like these habitats and these processes that have sort of evolved over millennia, just so that we can like get another ship across, I think really is something we need to critically engage with.
We also have to look at geopolitical security, because we now have more openings for warships and such to impinge upon other nations' territory.
Yeah.
What about the melting of the boreal permafrost? We're talking about feedback loops.
Yeah, so exactly, another one of these positive feedback loops. As we know, historically within the record, we have had different levels of warming before humans even evolved, right? And we're able to adapt to current sort of Holocene-like conditions within which we've thrived. There have been various processes of sort of extreme warming and cooling, and with that, we've had different levels of vegetation in different parts of the world. And as that vegetation has died off, this is actually where we get our fossil fuels from. It's actually sort of ergo the carbon. It's actually the breakdown of organic matter that is sort of being compressed into oils. You have not exactly, but similar types of processes that are actually locked in the permafrost. So there's ice over, which means that we've sequestered a lot of this organic material and matter that was former vegetation in these areas, got very cold. no longer have that vegetation, but it's locked up in this permafrost. But as that ice starts to melt, it exposes us to these gases. I mean, when sort of you have decomposing matter, you sort of have methane, etc., emerging. It's basically exactly the same thing. And these are, as we know, so carbon dioxide is one sort of greenhouse gas, but methane actually has a much higher level of forcing. So it sort of one molecule of methane is significantly more impactful from a climate change perspective than one molecule of carbon dioxide. And so the release of this methane, at the moment, it's nowhere near the level of impact that just our fossil fuel emissions are, but it is quite significant when we're looking at the need for, as I was mentioning before, not just stopping our emissions now, but actually looking at how we're going to go back towards temperatures that we need in order to rectify some of these systems processes. Sort of, we talk about overshoot and then return. The role that even these just like sort of couple of 0.0 degrees, right, that are impacted from this at the moment still has a significant impact for our ability to actually draw down. But also, again, this feedback loop, right, is that we're seeing only parts of this melting now. But again, increased warming, increased thawing, therefore increased emissions of these methanes, and this positive feedback loop that could have, again, disastrous consequences over longer timeframes.
You also touched on the East Antarctic ice sheet. That's the biggest. That's the world's largest ice sheet. I mean, if Greenland's the second, this is number one. 3 miles thick, 4,800 meters. It contains enough water to raise ocean levels over 50 meters. That's 175 foot of sea level rise. So were that to reach a tipping point, I mean, the world as we know it has changed. It's suddenly water world.
Yeah, once we get to that point, I think it's we're entering fundamental reconfigurations, right? I think we need to be focusing a lot more on those earlier tipping points that we have just high levels of certainty on. The really terrifying thing is, and this is what I've heard from experts, and we're talking about these levels of certainty, right, between like what is the actual threshold. And, science is never going to say it's point X and that's when it's going to tip, because that's not how complex systems work. So it's about anticipatory governance, being precautionary in terms of knowing that these things could be coming, and, as you say, acting accordingly so that we don't go over these thresholds. For example, with AMOC, some of these, because of the sensitivity in the system to these self-reinforcing feedbacks, that we may have already crossed what the system itself has as a threshold, but we're not seeing the impacts of that, right? That will take another 10, 20, 30 years in order to actually see it. So we may have, and so this is an ongoing debate, so not saying that we have, but the hypothetical of if we have reached a tipping point within the AMOC system, and there isn't sort of evidence right now that this has happened, that we would only be seeing those implications in 2050, 2060, for instance, right? And by that stage, again, it's far too late to go back and fix sort of going over that threshold 30 years ago, right? So it would be the same thing with the East Antarctic ice sheet, as you say, with like much more severe repercussions, is that by the time you are actually looking at this, it is far too late to do anything about it, which is why, scientists really are just sort of sending the warning signals around these nonlinear dynamics within these Earth system processes.
We've got 2 major ocean current systems on the tipping point list. The North Atlantic's SPG convection system, that's a subpolar gyre. Basically an extension of the Gulf Stream that brings warmer equatorial waters to the north. Most people are saying, yeah, we've hit the tipping point there. And, when that goes, that's going to lead to rapid cooling along the United States eastern seaboard and Western Europe. The big difference with the AMOC is that it's not only bringing that warm water north, but it brings the cold water back to the equator, basically moderating temperatures planet-wide and interconnecting with the other big currents with the other oceans. If that was to collapse, and that's where you're talking 2050, 2060, then we're going to see major freezing events in the northern regions of the United States and Europe, and probably cooking events down by the equator. So it affects the whole world. It really does.
No, for sure. And I think, this is where the science communication starts to become important, right? And you saw that I think was it last year that the US also had those really cold events with these snaps going down like unprecedented across sort of Boston. And everyone was like, oh, what is this global warming business that you're talking about,
Exactly.
right? Like, which is why I think talking about climate change could lead to like -5 degrees in certain parts of the world because of these systems, right? So it's not so the warming globally is obviously the important impact that we do need to be looking at. But the implication of that warming could lead to, as you say, these freezing events. And that subpolar gyre again, I was talking about and these are coupled and linked to the ice sheet melt, right? Because of this fresh water sort of just breaking down these pumps. They're largely heat pumps, as you say, that sort of work in different parts around the world through the oceans. And yeah, I mean, again, these are just almost impossible to imagine, right? Like the water world. I mean, looking at a Western Europe that is just almost unlivable because it's so cold. Or you then start to look at, and again, coming into these more social, ecological, like the human responses to that, which is just, do we just heat everything up? Warming again, the use of electricity, energy, power starts to become another reinforcing loop, right? Because you're not going to get everyone migrating necessarily from Northern Europe, from the US. Yeah, so just completely unfathomable the implications that would have, I think, for just how society thrives. I think we're really getting into an almost apocalyptic type scenario at that point. Just something that we've never had to deal with as society before.
That leaves the final tipping point, which is the collapse of the Amazon rainforest. What are the social and ecological impacts of losing the Amazon rainforest?
The role that the Amazon rainforest plays within global climate is critical. It both acts as a carbon sequestration mechanism, right? But it also, because of the extent to which you have these evapotranspiration processes, so sort of precipitation, moisture that happens through the trees, you also have a really important impact on precipitation events. So of course, when we talk about climate, it's not just about temperature, it's also about where you're going to see rain or not, and droughts and some of these extreme events. So the Amazon has a really critical role to play in global climate processes from the precipitation perspective. But the thing with these biological or these biosphere processes is that they can also bounce back. Like there's resilience within some of these systems. Same with coral reefs. But the more that you start to impact them, right, the lower their resilience starts to be. And deforestation is one of those clear impacts, right? It is breaking down, it is making the Amazon more vulnerable to these climate change effects. So if you were so basically you're getting a double whammy, right? Like you're hitting it in multiple ways. You're like, there's very little that the system is going to be able to do. But the important aspect of that, it means that we have direct agency over some of these social ecological processes. So in some instances, it can seem almost impossible for many countries, particularly in the global south, to actually address climate impacts, right? Because they aren't the major emitters. They're not sort of causing the problem. It's not where mitigation necessarily is going to be the most useful, but they're sitting at the impacts of this. So you're looking at the warm water coral reefs, which are happening in the tropics, largely in the global south. I mean, I think over 1 billion people are reliant on coral reef ecosystems to meet their food and livelihood needs. Improved local management around reduced impacts from fishing, reduced impacts from sort of tourism or people just literally breaking down, looking at improved sort of water systems so you don't have runoff from land sort of entering into these coral reefs and sort of making them more vulnerable. The same with the Amazon, right? If you reduce deforestation, if you actually look at other kinds of mechanisms that could start protecting these systems, they may actually be a lot more resilient to some of these broader climate impacts that you're starting to see. So there is agency. I think this is important to emphasize that unlike AMOC, where there's not necessarily something that you could put in and suddenly get this reconfiguration of the system bouncing back, other than at that climate level, with the Amazon, with coral reefs, with some of these other biosphere tipping points, you do have agency, and you can either exacerbate and make it worse through deforestation, or you can make it better, but like sort of improving your management of these systems. But again, they have fundamental roles to play. I was mentioning just precipitation from the Amazon perspective, the livelihoods and food security implications from coral reefs. They really are quite critical systems, and much more closely coupled to humans and sort of what we need to survive.
You're listening to the Climate Hour. I'm your host, Bob Grove. We're speaking with Laura Pereira about climate tipping points. Let's discuss governance. When the world ratified the 2015 Paris Agreement, they agreed to keep global warming, below 1.5 degrees Celsius, ideally. But here we are a decade later, we've blown past 1.5. We're now negotiating to keep global warming in the 2 to 2.5 degree range. And, that's where some of these tipping points start kicking in. And I'm reading that Europe is actively preparing for 3 degrees of warming. So, we've moved past what was reasonable when we started this process. How do we develop effective governance strategies to prevent these global tipping points, particularly when we see this kind of backsliding?
Yeah. So it's a two-pronged approach. I think still first and foremost, climate mitigation is the most critical governance issue that we have. We need to stop emitting greenhouse gas emissions that are causing climate change. And that's that fundamental endpoint. We know how to solve the climate crisis. It is about reducing our greenhouse gas emissions in our transport systems, our food systems, our energy, etc. This is not rocket science. We've known how to do it for ages. We don't need further kinds of solutions because the implications of that and the uncertainty, particularly around, for example, solar radiation management, could lead exactly to these kinds of winter events, like a complete shock into the system that no ecosystem is able to sort of adapt to, because you're suddenly going from this warming, which you were starting to adapt to, into this sort of like freezing. And again, the uncertainty around the science of what this is going to do, or sort of if it happens over Asia, the implications for the US, or for if it happens in Europe, the implications for Africa. It's a very, very regional, complex idea. And so the governance, I think, from that side is also very important, that just because we have these almost irreversible, in some instances, thresholds, does not justify the need for these kinds of technological engineering solutions, because those are likely to lead to even worse outcomes further down. So I think that's an important thing, because I think largely tipping points have been taken up by that community pushing engineering solutions, which I think is problematic. So that's the first side. We just need to do climate mitigation in the way that it's been very clear for the past 30 years, right? Even more so since the first IPCC report. So that's number one. At the same time, we also need to prepare. We need to anticipate what these things are going to look like in the future. And there was an interesting discussion that I was having with my colleague Jesse Abrams around. You might be aware of the new climate scenarios that are going into the IPCC sort of 7th assessment report, where they're saying we're no longer at that high-end threshold of SSP5 8.5, which is great. It means that we have actually done some things to sort of not be on that trajectory. They're still pretty bad trajectories. That was a really, really awful world that we would have been in. So it's good that we don't have that. But we have probably, and this was problematically used in some instances by the climate science community, to almost look at the highest level of impact that we could be seeing. Sort of that was the scenario that we used for that. And this is where you look at risk assessment, you look at sort of what is the thing that I do need to be put in place in case this happens, because this is such a bad impact that there's no ways that we can allow this to happen. Therefore, we need to start adapting and putting mechanisms in place now. Your walls around the Netherlands, for instance, right? Sort of sea walls, keeping sort of sea level rise at bay to a certain extent. What we need from a tipping point science is not that sort of extreme SSP5 8.5 degree sort of warming. So it's not about the warming levels, but it's about the impact levels and sort of the impacts that you can see even from lower levels of warming. For example, as you were saying, 2 degrees, 2.5 degrees, where you're starting to see a lot of these feedbacks happening, right? And so it's not necessarily the amount of emissions that sort of we have, but it's actually just the impact on the climate system that could have some of these really disastrous effects if you sort of reach a threshold, if you start having these cascades, so one temperature threshold. So I think there's a dampening effect between AMOC and Amazon collapse, but there's sort of positive reinforcing cascades between some others. So I won't go into the technicalities behind that, but you can see how one could set up a trade chain reaction, sort of subsequently going down. And the key thing is to actually halt that process. But as you say, we also need to think through what are the impacts? Like if that were to happen, what would the world look like? And therefore, what are the governance mechanisms we should be putting in place to avoid that at all costs, but also to acknowledge that, well, if this is going to happen, what is it that we can do, particularly in the most vulnerable countries that are going to be at the forefront of this, whether it's sea loss, whether it's those extreme heat events that we were talking about in the tropics, whether it's the complete loss of agricultural production potential, whether it's the loss of fisheries because of the reconfiguration of climate, of upwelling systems, or coral reef collapse, etc. So to think through what these impacts could be, to anticipate them. So this is anticipatory governance, and then come up with governance mechanisms in the present that can help us build our resilience or our ability to adapt or fundamentally transform and reconfigure sort of our systems, that we move away from, and it's really horrible to think about, to move away from a fishing dependent society, because we're not actually going to be able to sustain our fisheries, for instance, right? And so relying on these systems that may not be around, do we need to look at alternative livelihood for people, which has deep cultural significance and identity implications and many other really important things to think about. But we do need to do some of that preparation so that we're not suddenly caught at this threshold event that just has repercussions that we're not prepared for. So I think it's really about that preparedness. But then, it comes down to those questions of how do you prepare for your small island state no longer existing, right? Like, I mean, these sorts of existential questions, which really are just really hard to grapple with from a governance perspective. And I think, it's, we can write reports, we can say these things, and you're like, we need to anticipate this and we need to prepare for like these worst case scenarios. But the implications of that for people on the ground is really harsh. And so that's why I keep on coming back to the climate mitigation, just getting that right. We know what we need to do is probably still the most important governance mechanism that we need to have, because it's only by doing that and by doing that well that we're going to be able to have a minimal sort of overshoot and return, where we may not actually be crossing some of these thresholds. Because as I said, there is fuzziness in some of these boundaries. It's not like suddenly the temperature goes to this and everything goes to hell. There is the ability to come back in some instances. And so that's what we need to be focusing on fundamentally at the end of the day.
I feel like tipping points, the importance of tipping points is increasing. You kind of touched on this. We have effective climate mitigation, and with the exception of the United States, global adoption of things like electric vehicles and solar and wind energy and battery storage, all those things are happening. Positive tipping points. I mean, globally, we're in this positive tipping point cycle where renewable energy and sustainable transportation is a fact in most places except the United States. And that's a separate discussion we can have. But the mitigation is there. It seems more and more we're moving towards what you suggested, that it's going to be those system feedbacks. The fact that we've already passed the tipping point for Greenland, for the boreal permafrost, those system impacts of them just accelerating on their own. We need to find solutions and governance to address how we're going to handle those.
No, for sure. And as I was mentioning, for example, the Amazon, there is an intervention, a governance intervention around climate mitigation that we need to address. But there are also governance mechanisms to make these systems less vulnerable, such as reducing deforestation. And that comes into food systems in Europe that rely on sort of on livestock production in these areas that are encroaching on the increasing soy to feed livestock and industrial systems. So there are multiple intervention points that you could look at to make these systems less vulnerable. Over and above the climate mitigation side of things. I was talking about good water management. So there are definitely good governance and also sort of interventions that no matter what you do, these are going to be good. So even if you're not crossing a threshold or a tipping point, this is still a good thing that we should be thinking about. So, for example, improved fisheries management in the Gulf of Guinea. Right now, that is important to sort of look at reduced illegal and unreported sort of fishing practices, maybe renegotiating how reliant some European fleets are from taking fish from here. So that does actually return to people in West Africa who are reliant on them. So improved fisheries governance is going to be good in the present and will also help us to respond more actively if we were to see a change in the upwelling system, for instance, right? So let's look at those. No matter what we do, this is going to be important. And thinking about the future just reinforces how important getting this right now is. So that's another important aspect to emphasize. I've spoken a lot about climate and the need for climate mitigation and like that being the main governance intervention. I'm going to put my other hat on, which is actually coming more from the biodiversity, ecosystem services, social justice, equity side of things, which is where you can also see a lot of problematic implications to climate mitigation and sort of, I was mentioning, the need to draw down carbon. So this idea that sort of we've emitted so much of these greenhouse gases that in order to return to safe levels of warming, which from the safe and just system boundaries perspective is actually 1 degree, not 1.5 degrees, requires us to actually remove some of this carbon dioxide, some of these greenhouse gases from the atmosphere, which quite often turns into problematic. Again, carbon dioxide removal in marine systems. Those are these technologies, these engineering technologies that I said we shouldn't be going down the route of because we don't know it's likely to have much more problematic outcomes. But tree planting, for instance, I was mentioning how trees are really good at sequestering carbon. But again, where are these trees being planted and who's benefiting from this? It's largely in the global south, right? So you're not talking about sort of removing all of these big urban areas and rewilding necessarily in Europe and planting trees, right? You're doing it in areas which don't necessarily have a lot of people in. Savannas have been misclassified as degraded forests, I think, since 2003, and the definition is still there. So it's like, oh, look at all these savanna landscapes. You go and a forest, plant trees everywhere around here. So yes, you might be getting like short-term carbon gains around that, and you'd be able to tick off your, we're actually doing our duty from whether it's a government or a business, increasingly are getting into these carbon credit schemes. But you're looking at, well, what are you trading that off against, right? Around the biodiversity that's actually thriving in these landscapes, around the fact that these are actually savannas. They're not degraded forests. They're their own ecosystem that have different types of fire regimes that actually have below ground storage of carbon in their grasses, much more than in their trees because these are sparse. And so sort of this misrepresentation of ecosystems in parts of the world that sort of weren't there when we were sort of defining the discipline of ecology, right, which are largely based on European ecosystems. These tend to get sidelined, and I think we could start to see very negative impacts, again, if these become tipping points, around conservation, around livelihoods, around some of these other important ecosystems that are kind of turned into these climate mitigation machines, right? And I think we need to be very aware of that. So that's one important thing, that we should not be, these nature-based solutions, we should not be using ecosystems in parts of the world as the solutions to problematic economic processes in other parts of the world, right? They're not there to solve problems. We need to solve those problems where they're happening. So that's where we come to things like you were mentioning electric vehicles, some of these other transitions, and those are really important. Something that I think I may have mentioned in the previous conversation that we had, but this idea around, well, actually, what is it we really need to be fixing within our transport system? Is it that I should still have my own car, but it should be an electric vehicle that is relying on batteries that require sort of lithium, cobalt, all of these sort of rare earth metals that are again, coming from what part of the world? Sort of, we look at the ongoing conflicts within the Congo. I mean, first they were trying to take uranium out of there. They were assassinating Lumumba. Now we're looking at sort of rebel fighting on around cobalt. So I think we can't take away the geopolitics of mining, right? Of these broader mechanisms of furthering injustices in order to, again, allow me to still have my lifestyle. I have my carbon out. It's an electric vehicle, so I'm suddenly carbon neutral. It's like, well, you may not be neutral in terms of other injustices. Or should we be focusing on just improving our public transport systems, right? What is transport supposed to do? Get you from A to B in the in the most efficient way possible, right? And you can't do that with public transport. And so let's put all of these batteries and all of these other technologies into our bus systems, into train, into rail, into actually looking at these kinds of infrastructure that everyone can benefit from, because there's no ways that there's enough of these metals for every single person in the world to have their own electric vehicle, right? And so it's not an equality based intervention. So I think just thinking through some of these repercussions, some of the long-term implications, those are also important governance mechanisms around these positive tipping points that, again, because you have these threshold self-reinforcing dynamics, we will also need to be cognizant of setting these off, because they could have ramifications that we haven't thought about around politics, around parts of the world that aren't necessarily able to respond to those. So I think there's also just a level of caution within setting off some of these positive social tipping points that we also need to be very aware of. And again, it's not just a move a button here and you can get this kind of response. And if this response is bad, you can go back. The whole point of these nonlinear dynamics is that they have these effects that will allow us to have much more impactful outcomes if they're right. So, for example, I think in the finance system, we can see some interesting things there. But also we need to be aware of some of these other implications if we're not just putting our climate carbon hat on.
Indeed. You've spoken a little bit about the warm area coral reefs, the regional tipping points of that. Another tipping point that I was surprised to read about is monsoon disruption. I mean, that's regional, but that's affecting Western Africa, Southeast Asia. And what surprised me personally to read is that the greatest number of people in the world are subject to risk from monsoon disruption. Can you talk about that?
Yeah, for sure. I mean, so we know within South Asia, Southeast Asia, that the monsoon is fundamentally how societies have evolved their processes, agriculture. I mean, this is just part and parcel of how societies thrive. So you almost see a double vulnerability there, because I was mentioning the cryosphere, I was mentioning the Himalayas, right? So like that is going to impact exactly that same group of people, which is where billions of humans are living. And a disruption to that, it's the same as I was mentioning for the other. It's agricultural production, it's heat, it's water, it's extreme flooding events, or like not having any of this water at all, right? So these changes in these systems that we've adapted to, which could have just fundamental implications for society, for life. There's an interesting one with the West African monsoon, which is actually looking at an increase in greening, sort of getting more water into the system that's actually quite dry. And this is an interesting one, because, the Sahel actually used to be sort of a savanna, right? It wasn't actually always as dry as it was. And then you had the shift in the monsoon system. So whether this would actually have some positive impacts from an agricultural greening perspective, ability to build more resilience within that part of the world, looking at the paleo record and trying to actually understand historically what that could have looked like. So we do actually have within human records like understandings of what that looked like. There could be some interesting aspects. So again, we don't talk about negative and positive necessarily. It's just about that these are thresholds, these are tipping events that have these following repercussions, and most of them are pretty dire, right? Some of them, as I said, can be dampening. So, for example, AMOC in the Amazon, I think. So it could be really bad for one thing, but it could allow different things to happen in other types of the system. So we're still working from a science perspective to understand those connections. But ultimately, when you're looking at impacts, we need to think of the impact of changing monsoon seasons or changing of the whole monsoon process within South Asia together, coupled with glacier loss, right? So these are about not just like one of these, but what are the multiple implications from just a fresh water system of, no longer having monsoon rains that you rely on and not having your rivers, or you have massive monsoons and floodings, and there's no way your infrastructure is going to be able to handle sort of these massive impacts on a regular basis again. So it's not just a one-off event. This is actually a systemic reconfiguration that you can't just easily respond to as a once-off event. These are all really important things that we need to be taking into account when we're thinking through this. But again, the science is never going to be 100% certain or sure about this is going to happen at this point and this is the impact. So we need to build governance mechanisms that can respond to these potential impacts without actually knowing the 100% truth of things. And I think that's also something we need to learn to deal with from a decision-making perspective.
And so we've spent a lot of time talking about these massive impacts of climate tipping points. I'd like to wrap up with maybe a discussion of positive tipping points. And, I'm thinking about social engineering and things like that. Positive tipping point is where positive feedbacks into the system is going to overwhelm the negative. Climate-denialism is an example of a negative feedback. But if enough people become educated in climate science and start believing in the reality of climate science, then that becomes a positive tipping point that can push back against that negative. We've already seen positive tipping points, as I mentioned earlier, the global adoption of solar and wind power. How do we go about identifying more positive tipping points?
Yeah. I think for me, there are two important areas of intervention that I think we could have some positive tipping effects in. So you were mentioning sort of just education and understanding. And I think that is an important aspect to act, but I think quite often people also feel quite helpless, right? So I have all of the information around the need to act around climate, but I'm sitting in Joburg and I don't have a public transport system, so I do still use my car to drive into work every day. So those sort of structural implications of with as much knowledge as we have, we still need the systems in place to allow us to act towards addressing climate. So again, putting it down onto individuals can also be problematic. In some instances, we need systems and structures to reconfigure around this. So this is where I think a 2-point aspect. Value systems, what it is we actually truly value. So tipping points to understand that actually it's not about capital accumulation, right? So when we're talking about what leaders that we're electing, sort of what are we actually valuing in society? I think there's an important conversation we need to have around that. Because is it about actually the value of a life of someone in the other end of the world that my actions do impact, right? Understanding those connections, I think reconfiguring into those more relational, not just sort of extractivist kind of ideologies, but moving into something else is a potential sort of value shift that we need to see. And we see it within food systems, for instance, like in a lot of those decisions that people can actually make at that value level and how societies elect officials or sort of govern themselves, for instance. The second, and this is the finance system. And I think this is actually probably where we have the most potential for positive tipping. And it really is just about no longer investing or taking money away from nature eroding activities, right, that are problematic, that are causing all of these, not just climate, but biodiversity loss and sort of pollution and plastics and all of those mechanisms, which are largely stuck within particular sort of quite concentrated set of financial instruments. So we're looking at our pension funds, right? These are, again, where individuals, right, are almost without agency perpetuating some of these problematic investments and shifting that finance into nature supporting activities where we are actually investing in renewable energies, where we are actually investing in agroecological production processes rather than large-scale industrial livestock processes that are causing Amazon deforestation, right? So I think that for me is probably the most important mechanism that everyone can be working on, because many of us have pensions, many of us are able to actually look and see where our money is going. We can put pressure on governments to actually act accordingly. We can start buying from these products rather than from those. I think there are different things that we can do, but also, investments, banks in particular, right? They need this anticipatory governance. They also don't want to be hit sort of in 10, 20 years time with this sudden reconfiguration. Central banks within Europe in particular is quite interested in this. So I think we are starting to see a shift. And I think, that for me would be one of the most important reconfigurations. We're investing in electric buses, for instance, maybe rather than electric cars, right? Let's just think about what that could look like. We're investing in improved rail transport in Europe, which is good, but it's still nowhere near where it needs to be in comparison to flying places, right? So for those of us to allow us to have those choices, to make more climate smart, more biodiversity smart, more equitable choices, we need the structures and systems and businesses in place. And that requires finance to be supporting those options rather than maintaining the status quo.
Thank you for joining us today. Where can our listeners go to learn more about your work?
I think from the tipping points perspective, you mentioned the Global Tipping Points report. There's a whole website that we've got up there with all of this information that talks everything from Earth system through to positive tipping. I also have my Stockholm Resilience Center site also has updated publications. And you can also find me on LinkedIn. I think that's where most of the information is sitting.
Thank you. And thank you to our listeners. You can learn more about the Climate Hour at climatehour.net. That's climatehour.net. This is the Climate Hour. I'm your host, Bob Grove.